All right, let's go ahead and get started. So welcome to the Arizona Blockathon.us event on Saturday, February the 2nd, 2019. We are at Local Motors in their Tempe, is this the research and development facility? Mm-hmm. And we're going to be looking at basically some, what could be done with this vehicle and autonomous vehicles in general, and beyond that, blockchain and cryptocurrency, and what are the opportunity sets. But anyway, I want to welcome everybody today. It's you being here is part of us creating something in Arizona where we can start to build and collaborate and create a community that's innovating in this space, this emerging space that I think, well, we're definitely all interested in. So let's talk a little bit about how it's going to go today. From 9:30 to 10, I'm going to talk about a few tool sets that might be of interest to you to build blockchains and do some things all the way from simple to fairly complex and sophisticated. And then Adam's going to talk about autonomous vehicles and the Ollies. And then we'll have Julian Geiger talking about zk-SNARKs and zero knowledge proofs. Then we'll talk for a little bit about the team formations or how we're going to approach the afternoon. We'll have lunch, come back about 1, and then, basically have about 3 hours to ideate and hack and so forth. I'm going to show you some hardware that you can play around with if you so choose. So, anybody have any questions? I would appreciate it if we could kind of go around. We got a small group, and just kind of introduce yourselves and what your interest is in the blockchain space, autonomous vehicles, and what you'd be interested in getting out of today. So, Adam, why don't you go ahead?
Okay. Some of you guys already know me. I'm Adam Plaster. I'm lead engineer for EV powertrain at Local Motors. I've been with the company for about 1.5 years. I work on the high voltage and low voltage systems on version 2.0 of the Ollie. So, I mean, you can see over here, the dev wheel. This is one of the first projects to, develop a new powertrain for the vehicle. And, we've taken that to basically the next generation, which is a 3D printed Ollie, which some of you have seen already just from tours, or you're at the last ASU event. We had, we did some, kind of just focus groups on the user experience and interaction. If you were at CES, it was in Velodyne's booth. So, that's what I do here, is just kind of finding out what, what would be the best possible use cases for the autonomous vehicle, which we'll get more into when I speak later. But, building the architecture of the vehicle so it could support that.
Cool. We'll talk a little bit more about Local Motors and why this is a really, really cool enterprise a little bit later. But cool. Bill.
Oh, okay. I'm Bill Maher. I design microcomputers, but I also run Phoenix as a meetup group. But the reason I'm interested in this is that I actually design a bunch of different robots. And so I would take, I won't be much smaller than this, nothing as big as this, but build, little robots that take pictures inside of buildings so we can get 3D models and represent it. Right now, my big thing is using high fidelity to simulate everything, so you can put your headset on and walk around the environments. So I'll get into that.
Cool. Yes.
My name is Tomasz Tekly. I work on different software, hardware projects myself. And blockchain, I did a couple of projects last year in space of smart contracts, and I'm basically interested in those use cases. Seems to be quite interesting, combining autonomous vehicles and blockchain. I guess this is what we are going to do today. So quite interested in this space.
Cool.
Thank you.
Bing?
Yeah, I'm being work with General Motors. I'm really interested in self-driving car and blockchain. So today I can come here just to learn how can we combine those together.
Cool. Very cool.
Yeah, Arshpada here. I'm currently a student at ASU, and I'm really interested in this because like I've previously worked on IT and blockchain projects. I really want to see how that can be applied into autonomous vehicles.
Did we meet over at HeatSync for the comma.io event? Maybe we didn't.
No.
Yeah, okay.
No, I don't think
Sorry.
it was there.
Yeah. Hey, Julian. Good, welcome. So, yeah, go ahead.
I don't think I know anyone else here.
Cool. I'm sorry, go ahead. Yeah, we're kind of introducing ourselves, Julian.
Sorry,
That's okay.
did I miss the front row yet?
We're going to come back to you. We'll
Okay, so
circle
I can
back
know
to you.
the front row.
Yeah, yeah.
Alright, so I'm Kiran and I'm a student from Arizona State University, and I'm interested in this because I also have done a little bit of project blockchain, but I did it's related to blockchain and autonomous flying aircrafts.
Oh,
So
cool.
it'd be really interesting to see how they can be, how the same idea can be applied on self-driving cars.
Awesome. Very cool.
Hi, I'm Raj, and I'm a researcher at ASU also. Actually, all of us work together on that. So I've been working on projects regarding carbon trading and energy trading, and I want to know, I want to like get also to know about how those use cases can merge with blockchain and autonomous vehicles. So that's why.
Cool. Are you familiar with Nori?
Yeah.
So Jason should be here, who's the architect for Nori, and they're doing a carbon removal trading platform.
Yeah.
So should definitely chat with Jason Horton, and he's the co-organizer of Dezer Blockchain, and he's also a member of the LLC, the Blockathon LLC, that's basically produces this. So cool.
Nice to meet you.
Yeah, yeah. Chad.
I'm Chad Islander. I've worked in web development and just moved down here to Arizona. I'm getting involved in figuring out what kind of blockchain scene is around here, and I'm probably more interested in app designs for autonomous cars and kind of how it can be applied.
Cool.
I'm Matt Oxendale. I'm in the retail automotive sector. Also one of the members of Arizona Blockathon putting on this event. And yeah, particularly from my background in automotive retail, I see autonomous vehicles coming and ultimately connected cars. And once we see that, I think there's real good application for decentralized technologies, and we'll have these, the autos will be connected into our lives in a number of different ways. So yeah, that's my interest as well.
Cool. Awesome. Oh, Julian, sorry.
Julian, I think I've already got my name. So I've got this project called Tunnel, which is taking Zcash and applying it to work on Ethereum for all tokens, essentially, as long as they adhere to a standard interface, like ERC20, 667, 777, etc. And I'm part of the Arizona Blockathon LLC as well.
Yep. Cool. Let's see. So I'm going to screen share so I can show you some presentations. And let's do application window. This one, share. Okay. So, if I can do this correctly. All right. Eileen, do you mind checking the you mind checking the live stream, making sure that the screen share is working properly? So, a little bit about me. I'm going to present from here, but hopefully you can see this stuff. I started Dezer Blockchain about, I don't know, 4 years ago now or whatever. I come from a telecommunications background, and the telecommunications companies like AT&T and Verizon have been working on some problems or at least some opportunities since basically 1999, when Sergey Brin and Larry Page were in their dorm room at Stanford coming up with Google. The telecoms figured out a way to basically create sort of harmony among all of our disparate addresses. However, after about 20 years of messing around with that, or let's say 15 years, they still hadn't really implemented the design the way it was envisioned. And when I saw blockchain, I said, aha, this is a way to do something really, really cool with naming, addressing, numbering, and identity. And that's basically my passion. So we started the blockathons, or the hacking sessions, about 2 years ago, I think. And the idea, the purpose of these, I mean, a lot of people come to these and they say, okay, we're going to win. Don't worry about winning. The value of these events is to get together, get to know one another, know what everybody's interested in. I mean, already the people that are here are awesome. All of you are awesome, and you all have an interest in creating something cool in this whole new realm. That's probably the biggest thing to get out of today, is just to get to know one another, no matter what you create or don't create. But the other part is to learn, to kind of exchange some ideas and some resources and so forth that we can continue to build upon. And if you don't know, if you don't follow Dezer Blockchain, the first Dezer Blockchain camp has started, and it's over by Grand Canyon University. It's in a huge, huge warehouse that's basically nothing is in it, including water and power. So we're operating off of generators. But one of the things that this provides, the Dezer Blockchain camps, is an opportunity to continue whatever happens today into a physical space. And we'll likely be having regular open hours on Thursdays, Fridays, and Saturdays to get started. And we've got the space to basically fly drones, run robots, do mesh networking, do whatever over there. So I invite you to come by and check that out. But my portion of the talks this morning is just to kind of bring up some tool sets that you might not be familiar with, that are like a good introduction to blockchain, in my view. And I'm going to start with real bare bones basic stuff, and then kind of work up to some newer stuff that I think might be of interest to you. And this is recorded. I don't have this into a presentation yet, but it's on my path to put this into a presentation. But so anyway, any questions at this point with all of that? Okay. And the other piece is, Julian and Jason, who will be here later, they know a lot about Ethereum. And a lot of people build and prototype in Ethereum. And, you're certainly welcome to mess around with that. It's just, I'm going to go over some things that are more like down to the metal, where you can actually load the code, change the code. It's all open source. And we're going to go over some JavaScript constructs, and then we'll go over some Go platforms that I've recently come across that I think are really, really cool. So, and we'll also talk a little bit about IPFS, the Interplanetary File System. If you're not familiar with that, that's what I think is one of the most promising projects that's out there. So that's what we're going to do for the next few minutes. And then I'll talk a little bit about some of these hardware kits that we can play around with if you choose to do so. So this is my favorite bare bones basic. If you don't know any coding, you don't know anything about blockchain, this platform or this tutorial which is in a browser, can also be downloaded, open source, JavaScript, all of that. This is probably the way to get introduced and have possibly an aha moment in terms of why is this construct so powerful. So this is basically blockchain demo on anders.com, and there are videos on here. There are ways to go step by step through a blockchain construct, and you don't need to know anything about coding to do this. The next step is something called zk-SNARKs, and this is like you can build a bare bones basic blockchain in like 70 lines of JavaScript. So this is kind of the next step after that anders.com blockchain 101 if you're interested. And even if you know just a little bit of JavaScript, you can load this and do something. Now, the fellow who put this together, Subg, has expanded this, and I frankly haven't gone through the mining and rewards and signing transactions, but I'm quite confident that he's done a good job of explaining these particular constructs. So any questions about these before I go on to the next level? All right, the next level, this is called NaiveCoin, and this is about 1,500 lines of JavaScript, and it's fairly robust in that you can do proof of work mining, there's wallets, there's transactions, and it combines the 1,500 lines of JavaScript that you run in the command line with Swagger. So that's sort of your API interface, and it does a good job of giving you some hands-on code. I've also, and I'm not highlighting it in this presentation, but I've also interfaced this with something called Node-RED, which is a powerful open source platform for controlling IoT devices and so forth. And I taught a class at University of Advancing Technology last semester, and we actually were able to control IoT devices with this NaiveCoin, so that when a block was formed, a light would come on. And I've got some Raspberry Pis set up over here, and if anybody's interested, I can go over that this afternoon, and you can actually play with NaiveCoin, you can play with Node-RED. The cool thing is that Node-RED allows you to, without downloading an app, control IoT devices from a smartphone just by going to an IP address that's on the network. And that's something that I think is really powerful, and the interface is really pretty clean on that. So any questions about all of that at this point? And I think I mentioned Node-RED was an open source project that was started by IBM and has been taken over by the JavaScript Foundation or whatever. So the next thing, this is my most recent discovery, which is a set of blog posts by something called Coral Health, or somebody or some group of people from Coral Health. And they've done about 5 or 6 blog posts that show how you can build a blockchain, much like NaiveCoin was done in JavaScript. You can do it in Golang, in like 200 lines of Golang. And that basic, and it's a health records company. So their particular application they're interested in is health records, a new way to manage and distribute health records, but it can be applied to pretty much any kind of record, including like legal records and so forth. And for those of you that are interested, I'm involved with a hackathon that's going to be coming up on February 22nd, 23rd, and 24th at ASU Law School. And we can actually use these blog posts in Golang to start to manage some records, legal records and so forth, if you're interested. And this Friday on February the 8th, I'm going to be doing a lunch and learn down at ASU Law School, where we'll be looking at the Golang constructs on this in a little more depth. So that's open, and you're welcome to attend that if you'd like. But ASU Law School, if you're not familiar, has a very active blockchain community, and some of the key issues in this space are figuring out the policy innovations and the governance around these blockchains. That's where there's an opportunity to innovate in addition to the code. And if you're not familiar, Arizona has some of the most forward-looking policymakers in the world in this space, where they're creating things like the FinTech Sandbox, ways to get into equity crowdfunding and so forth, that are hopefully designed to take the old constructs, the legacy rules and regulations, and move them into the contemporary. And part of our opportunity set with Dezer Blockchain and the Arizona Blockathon events is to kind of innovate with that. And to kind of circle back to ASU, combining the technical talent that's in this room with the legal talent that's at ASU, I think could be a very powerful combination, if that makes sense. So let's go into the Golang constructs. I'll just show you the blog posts. So this is post number 1 that was created January 28th of last year, and it's basically showing how you can create a blockchain in like 200 lines of Go. The next is how do you network the nodes, and however this is using a centralized server for the networking construct. The next post is how to do blockchain mining, basically proof of work. But the next post is how to do proof of stake. And I think that's particularly interesting approach to this. And I'm interested in exploring proof of stake for sure in kind of a novel way. And then there's something called libp2p in the IPFS world, and this post talks about libp2p and how to do pure P2P environment and setup without the centralized server. And then the last post that I want to bring to your attention, there are actually a few more. This is one of the most exciting things that I've seen, which is how to combine IPFS, which is a content address protocol for file management, with blockchain, with encryption, so that you're actually creating a hash of encrypted files and hosting that hash in a public way, but it only points to an encrypted file. So I think this is one of the most exciting things, both in record management for health records, legal records, etc., data, but also in cybersecurity. This gets out of the hardened perimeter model of our current cybersecurity, and I think this combined with some multi-signature constructs could be really, really powerful. So, any questions about all that?
So is this guy trying to use Golang as a quick way to do concepts, or is he trying to come up with a product that is like to production level?
They're coming up with a product in health records that's production ready. The point, if you're anybody familiar or coding Golang? Okay, in my view, Golang is the language of choice for blockchain because it's designed to be distributed, and it actually was, let's say, inspired, if not a derivative of something called Plan 9, which was an early attempt by like AT&T and some of the Unix folks and whatever to come up with a decentralized distributed language. And basically, some folks at Google got together in the late 2007, 2008, took some of the fundamental concepts from Plan 9 and then created Golang. So,
yeah, I'm just kind of wondering how you could use that for actual production system.
For Golang,
Yeah.
or for this construct of hashed encrypted files?
Yeah, for everything. Is this like the equivalent of APL, or is it like Pascal, or these languages that are only used for teaching?
No, Golang's totally in production. Yeah. Golang's.
So it's got debuggers, libraries,
Oh, yeah.
support, all of that stuff.
It's opinionated, and there's a growing community. In fact, the people that have been fans and basically active in the Node.js community are shifting to Golang, in my view. And part of it is because this is a compiled, strongly typed language, which JavaScript isn't. And I think a lot of people are getting really, really frustrated with Node.js because of the dependency problems. And I think there's some huge security issues in the dependencies that are associated with Node.js. So a lot of people are looking at Golang as a sort of next step from Node.js.
Yeah.
A lot of infrastructure frameworks are written in Go now. So kind of replacement for C, those type of, because it's safer with memory, stuff like that. But yeah, it's been in production for many years.
Yeah, there's
and it's extremely readable, really easy to learn.
Yeah, good. Yeah, I'm just wondering if, because we need to do something for production for replacing JavaScript. It was pretty messy. So of course, you got people wanting to do Haskell and all these other languages. So now it's yet another battle of the next language. So I'm just kind of wondering where that fits in.
Well, so let's talk about functional programming, because I'm learning and attracted to functional programming for multiple reasons. There's actually a book that was published 6 months ago or so that shows you how to program in a functional programming style with Golang. So it is compatible. And Golang is, hey Jason, hello. Golang is, works with assembly, with C, C++. So, there's some nice complements there, basically. So, have you programmed in Go?
I started some, and I'm looking to, so like HashiCorp tools are all written in Go. Again, it's more like infrastructure, but it's fairly simple to learn. And yeah, I mean, if we start talking about functional languages, that's Haskell, that's total shift. And for many people, just having something a little bit better than C or C++ in terms of memory management, readability, Golang is actually a good choice. And it's dependencies, it's always a hell. But I think we're getting to some good place there as well.
Yeah, and like JavaScript, you can write your own packages in Golang, all that, and there's an extensive set of libraries that are already.
And you can compile to different OSs, so that helps as well.
Yeah, and you can also run Golang on small board computers, Raspberry Pis, and that sort of thing. So that's pretty attractive, as well as IPFS will run on small board computers and so forth. I don't have IPFS set up on the Raspberry Pis yet, but I do have Golang on at least one of these Pis. So, cool. Jason, you want to introduce yourself?
Yeah, sorry, it's very late. Name's Jason. I've been working in blockchain for the past couple of years, kind of been involved in the space since probably 2010. Working on a project building on Ethereum, basically building a carbon offset trading marketplace.
Well, you need to talk with this gentleman because he's from ASU and they're working on a similar set of projects. Actually, it's not carbon removal. Are you doing carbon removal or trading?
Not removal. It's trading. Yeah.
Trading.
Yeah, we're trading the actual removal.
Yeah.
So basically incentivizing people to remove carbon from the atmosphere.
Yeah. So.
Because remember, it was like it was just keeping a track of it in Hyperledger, right?
Keeping a track of it and also allowing them to keeping a track of the transactions which involve the traders. Both of these things.
Cool. So I think that's what I wanted to cover in terms of the technical tool set. Let's see, I think I've got one more thing, and I'm not even sure what it is. Oh, that's Julian's presentation. So I've got some things that you might be interested in, maybe not today, but these are the type of things that we're going to be hacking on at the Dezer Blockchain camps. Here's a robot that you can build. This is from SparkFun. And then here's another, I think this is a little more simplified robotic car, vehicle, or whatever. This, however, is a set of 2 stereo cameras. So let's see if so the cool thing that's possible with this is, and this is kind of teeing up Adam's talk on Ollie, but this is a stereo camera that will give basically depth of field. And we might not get to it today, but imagine mounting this stereo camera on one of these robots and driving it around and starting to experiment with remote drivers for an Ollie. And that's kind of an opportunity set. Now, how does blockchain fit in with that? I think, managing the addresses and, managing who's controlling the vehicle at what particular time could be conducive to the blockchain along with other things. And certainly, experimenting with cryptocurrency associated with payments and that sort of thing with the Ollie is interesting. But this is a way to kind of get started on a new realm of, instead of fully autonomous vehicles, basically vehicles and devices that could be sort of like a cobot. I don't know if you've heard of the term cobot, but what's kind of taken off, as far as I can tell, in manufacturing is the merger of robots with humans and sort of optimizing how what humans do best with what robots do best. So an opportunity set for us today, or from this point on in Arizona, is to start to experiment with, is there something available by having like a drone pilot for these vehicles or any other vehicles? And probably what's held that back is a lot of the networking latency and how do you construct connections, connectivity, so that the latency is very, very little or very, very low. And I think IPFS is a pathway that might open up some opportunities with that. So any questions about all that? Okay, cool. Well, then I'll turn it over to, oh, I'm sorry, Chad, you had a question.
You answered it. It was about the IPFS.
Okay, cool. So I'll turn it over to Adam Flaster of Local Motors, and I'll pull up your presentation. Let's see.
make sure at the end of it, I touch a little bit on the cobot stuff. I have it more on the infrastructure, the financial infrastructure of doing autonomous vehicles, but I did want to touch base a little bit on that, especially with the costs associated with LiDARs and compute on a vehicle, and kind of right now the how it can be a bit cost prohibitive.
Okay.
For some of these.
Well,
especially if you're selling to, trying to sell a vehicle to the public with some levels of autonomy. It's not really autonomous for everybody.
Okay. And by the way, the cost on the stereo camera is like $190. So, and just tell me when you want to change slides, Adam, because we don't have a remote for this, unfortunately.
Okay. Well, as I said earlier, I'm Adam Plaster. I'm the lead engineer for EV Powertrain. I've been with Local Motors for a year and a half. My primary responsibility is developing the next level architecture, both high voltage and low voltage on Ollie, which our first generation vehicle is currently being produced in Chandler, our microfactory there. We are now gearing up for production of pilots for the 3D printed version of that vehicle. So I'm going to give you a high level view of Local Motors. I'm part of R&D, which is a group inside of LaunchForce. LaunchForce's goal is to basically do co-creation projects with partners. So basically, somebody in industry would come to us with looking for some sort of ideation on a product concept. A lot of times we'd run co-creation competitions where people out of the community would submit ideas. And whoever had the best one would win that idea. But R&D comes in afterwards to basically take that concept and build a prototype and betas and then pre-production concepts of that product, that vehicle. So it's something that's robust, thought out enough where we could basically pass it on to Local Motors, which runs the microfactories and will build these vehicles, take care of field support and service of them. So we were part of the Local Motors industry umbrella, but that's the structure of the company, how things work, and our part over in R&D and LaunchForce of building this new area of automotive and transportation. So, next slide.
What does Ollie stand for?
It's a name. It's part of when it was originally.
Oh, it's not an acronym?
It's not an acronym. So at Local Motors, we believe a mobility revolution is happening. Whether you look at it with Lyft or Uber with on-demand mobility, you can look at one good example of on-demand, transportation solutions is Jump or Up or OFO or Linebelt, right? Where you've seen them transition really fast from having pedal bikes to having the scooters and kind of a hybrid electric bike to GM transitioning over to autonomy and EVs, Ford investing heavily in the old train station in Detroit to create an autonomy division over there. There's a lot of things that are shifting in the automotive world, and that's most of my background of doing alternative energy vehicles from passenger car to Class 8 truck. Just seeing this evolution over the last 10 years to this, what is the value prop to customers, in this case users of autonomous vehicles, whether you're going to sell them, whether you're going to offer a subscription model, which some automakers are doing with their cars. And it's this real paradigm shift of how are people really going to consume, use mobility. And this is why we create Ollie, which is your friendly neighborhood autonomous shuttle. So,
nice.
And this is the first generation. It's currently produced in Chandler. It's the first co-created autonomous electric vehicle shuttle. It's mainly a last mile solution. So it's in this thing of a neighborhood electric vehicle. Top speed's about 25 miles an hour. It's not meant to be the typical thing of like what you think about your car. It's just supposed to be something on the spot for you to consume to get where you need to go. And it's, how I'd like to think of it more of not like, a bus or a shuttle, but more of you thinking of it as some things are going with the amount of computers and data that the stuff is doing. It's basically a mobile server on wheel. It's almost like a device that offers transportation as a solution. And that's kind of the thing of how these products are evolving, looking at how people would really use them, what do you really need to put into them, not just the original thing with electric vehicles of range anxiety, but also what kind of things you need from a UI, UX perspective and user experience. Go to the next one. So, I touched a little bit on Wadsworth and Local Motors. Our main thing, and this is a picture of our Flagship microfactory in Knoxville. These microfactories are physical operating spaces. Like they're basically designed for rapid prototyping, modular experimentation, small batch manufacturing. We're not believing in economies of scale, but economies of scope. So, come up with platforms that could be adapted to focus, be tailored to a specific user or customer application. And these, we have one microfactory, like I said, we have one microfactory here in Chandler. This one's in Knoxville. The one in Knoxville mainly deals with 3D printing. You go to the next slide. And this is a picture of the shop floor. So as I said, Ollie 2.0 is a 3D printed vehicle. You can see this is our previous generation 3D printer and machining area. Now we have a 3D printer that sits next to this. That's the entire length of that 3D prints the entire chassis, both the upper and lower section, machines it, and then there's some prepping for the crew over there, and then it gets shipped over here for us to do the assembly of the vehicle. And that's, if you can do the next slide, that's where we get to Ollie 2.0, which was built here. If you guys looked at the video, that's the vehicle we had at CES, but this is beta 2 that we constructed. You can see, how we're dealing with these issues of UI, UX, how people interact with it. You can see that from the lighting perspective. You can see with the Tower of Wisdom we have there with the screens, which I'll get more of into with some of our pictures. But
Adam, by Tower of Wisdom, you're talking about the monitors that are right along the side.
We have both inside and out. We have screens. The central one has a touch foil for people to basically build applications to interact with the Ollie, whether you want to go someplace or whether you're trying to search for what you want to do. The idea here is that you hail the vehicle with your phone. Has voice commands, so your IBM Watson, or some cases Alexa. Talk to it, ask it some questions. Basically, tell it where you want to go, and the vehicle will take you there. But that's a high level concept, and I think a lot of people here understand that that's easier said than done. There's a lot of things that just on the software side, getting it to do that and infrastructure. Next slide. But this is kind of the thing where you get into autonomous vehicles, defining the use case. In our case with the architecture of the vehicle is down to 4 things that we know it has to go into, especially for regulations with autonomous vehicles. Whether you have an exemption or not, like a lot of these are being placed on private property, private roads, private campuses. So like our use cases for this these first pilot programs are more colleges, corporate campuses, municipality, but also resorts and amusement parks. But our whole thing of the architecture is basically this empty box strategy of what does it need versus what does the user want. We're going to basically provide this empty box with the architecture in there, and the customer can basically Bob Ross on a blank canvas whatever they want their user experience to be.
That's a poor selection, Bob Ross.
What is that? What?
He was this guy, this paint by number.
The afro?
Yeah, with the afro,
Yeah.
Here's a happy little flower.
Okay,
But you get the joke. Yeah.
Is he still going? I haven't
No,
seen
he's
I think he's pushing up flowers now.
I remember seeing it when I was in high school. Yeah.
But you get the pop culture reference, but it's kind of saying like what kind of world does our customer want to create for their user? and hence the joke, and the expression. But it is a thing that we don't want to get into, that whole world of trying to figure out somebody else's user experience. We just want to offer them a device that provides transportation, and similar to how the SDK, the software development kits were for iPhones. They basically have a kit to build their own software that deals with that on the higher level of the vehicle, and just have them manage it.
Would you talk a little bit about the approach of Local Motors as an enterprise, and how there's a community around the world that helps design, and the whole collaborative nature of Local Motors, I think, is really, really cool. And it's so, part and parcel with the blockchain and decentralized web constructs.
Yeah, this is, I try to give because I work with a lot of incredible people that can summarize it very well, but my level of trying to describe it like an engineer and coming from the automotive world is you deal with this real challenging thing of how do you get product market fit. And for either passenger car, even truck and bus world, where you have low volume, infinite custom configurations. There's this really interesting thing with Launch4 for doing co-creation projects, where they launch these community collaborations. Here's our partner, whether it's somebody like what we just did recently with the Marine Corps with this modular logistics vehicle, to how Ollie was produced, like these ideas from the community of what would you really want this product to do, or how would you want to interface with it. So kind of just going out of the community and just saying, hey, what would you really want in a product, instead of, in some cases like corporate America, like being in an insulated environment, even a bubble, trying to ideate what people are really going to want. You have the community immediately coming back to you, what would really get them jazzed, and what would they be really excited to use, whether it's mobility. There were some things where we built some appliance concepts. There's all sorts of things where the Launch4 platform has been used to really come up what products do people really want. And that's the whole thing about the collaboration and the community, and what you see on that.
Is there a financial incentive for people to bring?
Yeah. So part of the thing with our partners with these collaborations is that there's basically whoever design wins basically there's a purse that you win, prize money, if you come up with a winning concept. So in case of the designer who came up with the Ollie, they won a prize, how many? I wonder. I think it was 50,000, and they also have royalties associated with the design. So it's there's not just immediate cash front investment, but there's also a long-term investment component of it for doing these kind of co-creation contests.
Cool.
It's like an incubator then, yeah.
And how would people find out about, are there bounties, or
so
if somebody had an idea for an Ollie, how would they go about submitting that idea and basically having a stake in that idea if it's adopted?
So what the thing is that you have to go to Launch4.io. We have contests listed on there, but you could also submit ideas for contests and coordinate with team members in Launch4 on what would be involved on setting that up, and developing the idea further to find partners who would help fund that initial project, and then the whole thing with having R&D come in after the project, and developing it further.
Okay, so if somebody has a bright idea for an Ollie, then you could go to Launch4 and submit that, have some sort of assurance that you're gonna, have a stake or a claim on that particular idea.
I'll go more into it with one. the first of tokenizing one of those projects with Ollie. So the idea of how you would take this platform and create a fleet, your own fleet to meet, a demand in the market that you see, and how you would do that co-creation project. So I can touch on it more, but the whole idea is dealing with that. You say an incubator, but that whole thing of how do you engage the public, how do you engage the community to make sure that there's really a fit for this before you go and you spend, $100,000, $500,000, $1 million into developing an idea further into an actual product.
Do you guys have any workshops that you offer, either virtually or in person, that talk about, could educate like communities or people on how to participate in this? I'm sure I haven't looked at Launchforth, but have you guys ever thought about doing that?
Yes, I know that in the past in Chandler they did community activities involving that. Most of what I know right now are just the community blogs, forums for basically whenever we have a competition coming up. Like what it was the one I brought up in Marine Corps, we had an island EV challenge with the idea of like how would you do transportation, create small vehicles for dealing with the transportation needs of areas that don't have the benefit of the infrastructure here, like in the continental United States or in Europe. So how do you service that market? Stuff like that.
Okay.
Yeah, my understanding is that you only have these workshops when it's basically funded by a big company. So somebody like Airbus would come in and create, some kind of contest, and then that would be a standalone thing, and then the Marine Corps would do another thing, and you'd go to that, and when it's over, it's shut down, and then they just go from one big company to another, right? That's my understanding. It's not like locally here where we'll just throw something together and there's really no sponsor per se.
Well, we'll get into that. That's part of the thing with using the the fintech sandbox and this, with the crowdfunding initiatives here of how we'd be able to create an entity, have the community fund it with some partners here in the community, and be able to have a faster way of deploying transportation solutions.
Okay, cool. Next slide.
Yeah. Anyways, okay, didn't realize you needed,
Do we need,
yeah, you need to quickly request access.
should I click on that?
Yeah, sorry for the technical delay, guys.
So request access again.
I'm just gonna need to do it with the other one.
Need to do it.
Have a public link.
Might as well go to the next slide. We'll have to come back to those.
Okay.
But yeah, just showing the vehicle operating.
Whoops. Sorry. Skipping ahead. Okay, go to the next slide.
Yeah. So, I mean, but this is part of getting the thing of autonomous vehicles that, it goes back to this thing of it being a device that offers transportation as a solution. One example was CES with Bosch with this concept, which was just a mock-up of an Internet of Things shuttle. So there's all these things that, all these devices, all these technologies that have to interact with the vehicle. And it gets into this thing of like how, what technology do we want on an Ollie? How do we want people to interact with it? And then it gets into a broader conversation of what are smart cities, what do they need to do? I mean, I've spoken, one which you had where you had the
we had the
Chief Information
Assistant Chief Information Officer of the City of Phoenix, and then the Deputy Chief Information Officer of the City of Phoenix, talking about the Phoenix Smart Cities initiatives, and this certainly fits into that.
Yeah, and so it's this thing of like, what is that? What is a smart city? There's one coming up with the Belmont Project, which is basically the city that Bill Gates is funding being built out here. But this whole thing, you have all these devices talking, you have vehicle-to-vehicle communication, vehicle-to-grid. it's more of this thing, well, it's great, you have all this technology, but how is that really servicing a customer or user? And so it gets in these things, well, having open APIs or having, some sort of thing where people have an infrastructure to build apps off of, to build applications so that you could have these vehicles interacting with businesses in the area greater ease. And that's what really kind of this conversation, it's not really touched upon at CES. It's more of cramming more technology into vehicles, and that's kind of the thing that is getting into the stuff of blockchain and how do you have that and how do you secure access and deal with these things of having it be secure, because that's another element that's keeping autonomous vehicles from being deployed as a cybersecurity issue.
So they basically want to promote the Bosch catalog, right? So,
Yeah, so Bosch, we were featuring LG's.
Explain like what Bosch does, which is pretty incredible.
Bosch is like one of the largest consumer electronics producers in the world, like along with LG. I mean, they produce appliances, they produce screens, they produce controllers, they produce. There's a lot of tech. I mean, same with LG. Kind of a better example of some of these things that would be on other than Bosch. LG produces screens, they produce sensors, they produce computers. Even batteries. There's a whole everything. And so, all of these guys, it's like, how do you incorporate their technology on a vehicle? So once again, you're providing a platform to put these things on. Not trying to just build this car from scratch. It's just providing once again, I would say the iPhone was probably the iPhone or Android's probably the best example of how you provide these devices that they can build, their user experience off of.
In that demo for CES, how many Bosch components were you trying to show off?
Well, no, this isn't ours. This is them trying to show off things. Like, so the at CES, like, it was us and Mercedes that had actual working vehicles there. Mercedes had this pod type concept, which was interesting, and it was a fully autonomous vehicle. And then we had Ollie there for supporting Velodyne with their technology. But a lot of these things from Kia, there was Honda had some stuff. There are all these things to try and what is autonomy going to be, and it was just no one had like a platform there that you could basically deploy this technology onto, and that's kind of the thing where I'm getting at. Where I go to the next one, and yeah, it's asking facts, but we basically provide this vehicle to Velodyne for basically a meeting space. And that's what we're providing. It's basically the space for users to interact with. So you can see people here on the left, all crowded in the hallway, kind of just hanging out, talking. But you kind of see here, we have, I guess just go to the next slide. But you can see here at Tower of Wisdom, up here we have Velodyne's LiDAR sensor data being displayed, and they're advertising, but it's kind of the same thing we would do with other vendors. It'd be advertising space or whatever information they want to convey. But these screens, this series of screens, both on the outside and the inside, with the center having a touch foil to basically build your interaction for your application. So people, whether they want to go somewhere or they want to search for something. That's kind of the idea of having that Tower of Wisdom interface with the vehicle. But it's like you're basically having somebody rent a space, for wherever they're wanting to go for the day, whether they're commuting to work, whether it's the weekend and they want to find something to do, whether it's their usual thing of where they live, or they want to find something new in their city. So whether if you're just a tourist and you just, touch down a new city, you're trying to figure out what to do. It's kind of like the thing of just, once again, a device that offers transportation as a service, but you're basically giving somebody a platform to build their experience off of. And that's kind of the thing of going into the blockchain applications. Next slide.
Before we get into the blockchain piece, Are there Ollies out there that are being used more like a mobile space, a mobile office, or a mobile living room, or?
No, I mean, we have pilot programs for that are deployed in, South Korea, Australia, University of Buffalo, Springfield. We have the Ollie Fleet Challenges through University of Sacramento, and we have other cities that are popping up to do those use case studies, but they're just basic transportation needs and more examination. This Ollie 2.0 is more of that evolution of looking at the market space and what would really be disruptive, of finding a real niche that no one's looking at and just saying, hey, let's create a platform that people could tailor what they want to do with transportation. So, I mean, we can't be like a traditional GM or Toyota or Honda with how we build vehicles like that. We don't want to be like one of our competitors, Navia. We want to just, or EasyWant, we want to focus on something and really focus on the user experience and master that, because that's an area where most people are just not focusing on. It's just, we don't want to be a bus manufacturer.
Right.
We want to be something
Even
different.
autonomous buses.
Correct.
Yeah. You literally are creating this digital experience that happens to be on wheels.
Yeah, and it's hence the whole being a digital OEM. So from this idea that we have this platform, we know what the capability is, its strengths, we could basically, work with these customers, to build these, what that's going to be, or tailor it in the software, our design software, and 3D print the chassis, and then install our equipment. I mean, the reason why we were doing 3D printed vehicles is that it speeds up the iteration of design. So whether we learn it on, through testing or for a customer deployment, we can update the designs on the chassis. We have at least a 20% weight savings, and then we have decreased part count. So instead of having to deal with all these brackets and structures and support equipment, if we know where these parts are going, we could basically engineer in to 3D printed chassis where those are going to mount. And so it helps with speeding up how fast we get a product out. And it's more of, it's more of like how you deal with economics of phones and servers and all that with speeding out deployment. And then once the use case is done, or that deployment is done, pulling it back, we could recycle the chassis, just shred it up since it's 3D printed plastic, and then we could, recycle the components or scrap them.
It also reduces the limitations of scaling, like a Tesla mega factory is pretty centralized, and this conceivably could be scaled all over the world, wherever you could have power and a minimum amount of utilities, right?
Yeah, the idea with Launchforth and Local Motors microfactories are that we do these co-creation projects. We do them anywhere in the world, and once there's that customer application is done and ready to be built, a microfactory will be set up to service that market.
Cool.
So how fast can you, let's say somebody came in and said, okay, I want to build this car that looks like the Wienermobile, let's say, right?
Okay.
It's painted by Bob Ross.
Yeah.
And we want to put this together. I mean, will it? Because a normal car design takes a lot longer, even though they have a platform strategy and all of that. So are you kind of going to like the regular platform strategy, but then on top of that, you're doing this 3D printing that allows you to like turn out a product, in weeks or months, or how long is that time? Because usually it's like,
I haven't been permission yet to disclose how long it takes, but I mean, we can have a chassis out within a day.
oh, that'd be cool.
So I can't disclose the actual hours it takes to print a machine, but
I'm just saying roughly. I mean, that's something that that you're trying to work to, right?
Yeah, so the idea here is that, like with known technology, like with the whole verification and validation process, that takes about 9 months. If you know what the product, like if you develop a platform, depending on whether it's feature add or just, customization, that can be 3 to 6 months. So it's trying to speed up that process to deliver just-in-time products, similar to how it is with consumer electronics.
Yeah. I'm just wondering, whether this is sort of like a rapid prototyping answer or a real production where you're cranking out thousands of these things.
I think it could be both.
It could be both, but I mean, the whole thing of economies of scope, like, is it really effective, and like throwing out like a whole bunch of the same thing? It's better to develop a platform and then customize it based on what people really need. Because at the same point, like if you started going in economies of scale and pumping out thousands of these, and you flood the market with it, you're kind of having a brand dilution because you have so many of them. How do you really, you're trying to have the right fit for what it needs to do. And it's just, a part of it also is just the cost of these things. The autonomy kits can be, in the 6-figure range. So instead of like dealing in the past, 10 years, we're seeing the EV supplier base evolve to the point where it's ubiquitous and very easy to get, batteries, get motors and inverters, get, electrical, like, AC and heat. Like, that stuff has come down in price, but you still have this whole thing of, paying for the sensor suites, the computers that need to be on board to run these systems, then you train them. I mean, this is one thing with the cobot thing where it might be better where you're doing a similar thing like, good example are airplanes. Like, most of the time that pilots are interacting with checking systems and operating the aircraft, it's when it's on the ground and then takeoff. And then once it's in the air, they're just checking because it's all automated. Of course, that they're set so that way they can control how much fuel they use, they control the ride, like everything is a regulated space of what they can't do. And so you're kind of getting this thing, if you use a cobot application, you have some level of autonomy where you're dispatching it, and then you have a human being monitoring it for just when it's doing something. Well, I would say when other human beings driving around it or walking around it or doing things that are out of the norm that it was trained to deal with. And then sometimes having, basically taking over control where it's something that the autonomy kit can't handle.
Yeah, it's kind of ironic because you're kind of almost going back to, like, say, the way the airplane companies work, where, when you want to buy an airplane, let's say you go to Boeing and they would tell you, oh, here's the plane, but this, and then there's a whole nother industry of people building the interiors
it's a very similar model, and that's especially with leasing, because you don't go out and buy a plane, you lease it, get somebody to take care of the interior, you pick your options, and then you run it, because you wouldn't go right out and buy planes just because of the expense.
Yeah, I mean, it's like yeah. Okay. Sorry.
We're running a little behind. Great questions, great conversation.
Yeah, so it goes into this whole thing of going into economics of it. So, like, going more into blockchain of how you, the example I like to use is how Amazon created this infrastructure for you to market, sell, and then deal with, distribution of your products. And so the whole idea of one application with blockchain with a fintech sandbox and crowdfunding is being able to have people create an LLC, be able to tokenize this whole process of the co-creation from the contest to design, for R&D to do the engineering and then build the prototypes, and then basically go to production and then deployment, and then being able to deal with the distribution of revenue based on those operations. So how do you instead of the normal model of transportation, public transportation, where you have bonds and people do studies and all this, you don't need to have a lot of infrastructure. If you have roads, and then you need to figure out where you're going to charge these things, and then you have some things on the back end for data and just other things. So to serve, whatever those other applications are based on your use, the idea is how do you create the packaging for all that to finance that and manage that, instead of dealing with the long delays with bond measures and then deal with legacy costs, and then how do you wind it down. You're basically creating a privatized way of deploying transportation solutions. And so this is one method for doing it, for just having community funded an LLC that then tokenizes the whole process, deals with that investment, and then has the feedback loop of going back to how you would distribute profits, update the product, or in this case, if somebody who's bigger, who is interested in the contracts that it's servicing from the subscription riders, somebody who would come in, buy up the tokens, basically own that system after that. So this is one concept of how we tokenize, but it gets down to two main applications. You want to go to the next one because I know we're sensitive on time here. So application A was one thing that was the project tokenization, which you just went over. Just you can tokenize the cash and project contributions through that whole co-creation process. So whoever contributed, how do they get, how their tokens are distributed, how they get paid off of that, and basically a prize, component as well as a vested component, and then secondary, distributing revenue to the rest of the token holders. And then the next one. And then what application do with asset utilization? So how do you manage and track these vehicles based on subscription holders? How do you manage payments from subscription holders and non? So how do you deal with wallet holders? So these ideas of like, you have the business side, but then you have also the thing of doing the financials of how people set up their application, how do they spend the money, when they deposit money, how they deal with billing, do you link it back to a credit card, trying to think of the one Congress member we had here.
Jeff Winninger?
Yeah, where he just said it best because he owns a business and he deals with credit. The issues with this, a lot of businesses like these, is that you don't have a delay that you need credit for with having transactions complete and deposit. All these things with dealing with cryptocurrency is all instantaneous. So building applications where people deposit money or it's linked to their account, but you can deal with those instantaneous transactions so they don't have to deal with credit and then paying service fees. On top of those service fees, paying interest if they're running up, a long-term bill with something. And then there's other things like we're talking about the cobot thing, or having people use pilot these remotely. So if you were dealing with something like an Uber or Lyft model where somebody's, they go to a central location or they're at home, they have a VR headset, they basically log in and dispatch, basically assign to either a single or group of vehicles, and then they pilot remotely, and then it logs and tracks that and pays them that way. So that's, try to keep it high level. I think that gets a lot of the meat and potatoes in this.
Cool. Is that it?
That's it.
Okay.
So,
Any questions, comments, so forth?
You gonna be here the rest of the day? Or?
Yeah.
And so Julian's going to talk about zero knowledge proofs.
Yeah.
Thanks, Adam. But just so you know, Eileen just went to get some pizza. So when she gets back, we'll have some lunch, and I'll talk a little bit. I think with this small group, we'll probably break into like 2 teams, but instead of having a 3-hour period, we'll just kind of ideate for an hour, put together a simple presentation, and then come back and present, and we'll wrap it up early if that sounds good to everybody. We don't have to get into the coding and all that stuff. And again, there will be an opportunity to gather and continue this conversation at the Dezer Blockchain camps. So, all right.
Yeah. I think for us, for some of those applications, we're not expecting to build that today. It's just looking for people who have concepts, and if there has, if it flushes out that it's something like taking the conversation further, developing those applications with those programs.
Yeah. So, all right, cool. So turn it over to Julian. You can talk about zk-SNARKs and so
I do
forth.
have my laptop. If we're gonna do some of the actual.
Oh, you are?
Like I could.
Uh,
VGA and mini display for it.
you don't have HDMI?
No, this is a 2010.
Got
Got a new motherboard.
But it still works, yeah.
Is there any way you can just open up your laptop?
Yeah, I could show that later.
Yeah,
So
why don't we do that?
that's towards the end. So
yeah.
So how many of you have heard of zk-SNARKs before?
I've heard you say it before.
What do you know, Chad? Right?
Just to show that information has not changed either in a transaction or can be verified. Passwords are the same as without revealing the password.
Yeah. So they are a type of zero knowledge proof where you can make a statement about some data without revealing what the data is. And you know the next slide, Jay. That's.
How did you come up with the name?
I didn't come up with the name. This is some researchers come up with the name.
Oh, that's an acronym.
Yeah. So ZK stands for zero knowledge. SNARKs are succinct, non-interactive arguments of knowledge. There were zero knowledge proofs before zk-SNARKs, but zk-SNARKs being non-interactive, you can verify with one transaction. Prior to that, zero knowledge proofs were interactive-based protocols. It's like you would have a bunch of data and they query it multiple times with making random decisions that you can't predict. And then they just keep doing that until they're convinced that you are telling the truth about the data. So that's high level what zero knowledge proofs are. zk-SNARKs are a form of that. So next slide. So zk-SNARKs are very complicated. There's a lot of cryptography involved, some like math and really meaty stuff. But we can think of a high level perspective, just as from a programming kind of perspective. So you take some source code that kind of represents what you want the program to do, and then you go through these transformations where you take the code and then convert it to a rank 1 constraint system where you write it all out as basically mathematical formulas using just multiplication and subtraction, like kind of doing binary types of things if you think in terms of that. But it's in a particular form where you only have one multiplication and you can have as many addition. And then you have an A, B, and it's equal to C. So you set up these constraints that do correspond to the original program. So you can take that rank 1 constraint system and go back to your source code. Of course, you would lose variable names and all that. But so then you use Lagrangian interpolation to create a bunch of polynomials to get a quadratic program. So when with the rank 1 constraint system, each constraint, like you refer to by an index, you evaluate the quadratic arithmetic program or the clock. At one of those points, you get the original constraint values back. So it's still a transformation. You can go back to the original. And then from there, you derive common reference string, which are basically your proving keys and verification keys. The general kind of workflow is you take your program, you go through this process, generate a proving key, verification key. Proving key is used by a prover to produce a proof. Verification used by the verifier to verify it. And there's a relation between those keys that varies between different types of SNARKs. I'm not going to get into that because this is using pairings and it's really complicated with the cryptography. It's fun to dig into, but it's really intense. I've got a 90-minute presentation if anyone wants to peek into the math and see like a specific proving system, but you go to the next slide for programming. So Chad kind of mentioned it, you can use it for passwords, but Zcash is a cryptocurrency that takes Bitcoin's code base and uses zk-SNARKs to achieve fully anonymous, it's been a word today that's so anonymous transactions where you have sender privacy, receiver privacy, and payment confidentiality. So you don't know who sent it, where it went, or even how much was sent. So that's one application of it. You can also use it for zero continuous service payments. So one example of that is you keep storage for people and they pay you for storing their data. And it's a way of you proving to them that you still have their data. You can generate zero knowledge proof for that. You can use it to achieve anonymous voting, similar to how Zcash operates. We can get into the actual techniques we use for that. The original purpose for zk-SNARKs were just computational outsourcing. So you can say, I've got this data, I don't have the hardware. Can you do this computation for me? And then the person goes, yeah, here's the result, and here's a proof verifying that the result was correctly computed. That's what the original intent was.
Has anybody held Zcash or Monero or any other?
I have Monero for mining.
Yeah,
Yeah.
Monero is a little different.
Monero,
1936, but
So Chad, you've held Zcash,
No, just one.
Monero?
Yeah.
Same here.
yeah,
Okay.
that uses ring signatures, which is a different technology, and it's kind of limited to where you can take an arbitrary computer program and turn it to a SNARK.
Okay.
Those are general applications of it.
Next slide.
Yeah. So most of stuff you do with SNARKs is using this one C++ library called libsnark, and it's like there's two different implementations inside there. There's gadget lib1 and gadget lib2. No one uses the new one. Everyone uses the old one because that's where the SHA-56 implementation is. And if you've ever dealt with C++ templates and actually liked it, then you might like playing with libsnark, but it's incredibly painful because different things are type arguments, and debugging that one is horrible outputs. But there are new implementations coming along based off of Rust. Zcash has got some new library for dealing with their new curves. But pretty much everything else that you will be using is either a wrapper around libsnark or it's based on it, if that makes sense. Because a lot of the researchers develop their code and actually think it's contributed to libsnark. So there's a lot of different implementations of proving systems.
Next.
Yeah. So Zcash originally used DCTV14. They updated it in 2015. That's before Zcash launched. And so that's kind of the original proving system, the first like really adequate zk-SNARK system. There are newer ones like Growth 16, which is used by the Zcash now in the sapling protocol. There are a lot of other ones in libsnark, and you can poke around and compare like performance. Growth 16 is, I think, the fastest. It has the least amount of errors and operations involved in verification. But these protocols do not usually provide what's called simulation extractability, which I think is best to describe it as a fancy way of saying replay protection for proofs. You could theoretically take someone's proof if they had not done any adequate measures of preventing such attacks. Take that and maybe modify it and then spend whatever it was trying to do and turn it to Zcash. But they use HMAX within their circuit as a workaround. So the proving system itself doesn't have simulation extractability, but because they have all these additional constraints that their proofs require, people can't just steal proofs and then mess up the transactions. So next slide. So there are different curves you can use. Zcash initially launched with EN128, which is an okay curve. They thought it was more secure than it really was. So they kind of hastened their switch within sapling to a newer curve. And this curve has another property where it's really easy for them to implement another elliptic curve inside the SNARK. I don't think this is a great context to get into the implementation of that, but let's see. We'll talk about that when we get to the code examples. So go to the next. So there are really three different types of things you can use, like three different core building blocks within a SNARK. The main kind of thing is just a simple commitment scheme. This is the password example that we'll actually be doing. So this is, you take something, everyone familiar with the hash function? Okay. So you can take something, hash it, and then reveal it later. Now, if you do this inside a zk-SNARK, you can prove that you know the hash without actually having to reveal it. And so this is a building block. You can reveal commit something inside a SNARK and then do something else with it. Well, I kind of just reveal, proving that you know something isn't super useful. You can just use the official signature. Next slide. So you can use the hash functions, though, to implement Merkle trees inside the SNARK to get what's called a cryptographic accumulator, which allows you to prove membership of a set, like a fixed set that everyone knows there's these things in the set. They could all just be commitments, and then you prove that you know one of the commitments. But so you can provide a Merkle path for the Merkle tree. Everyone familiar with the Merkle tree? Everyone? Yeah? Okay. It's just a binary tree using hash functions to compute a root node. And if you have a fixed step one, it's relatively easy. You just make an foundation of the commitment here, and then you can just provide all the ones that we need to produce a root map. And it's a relatively useful technique to get the prove that you know something. And then, so jub. So I kind of already touched on this. You can implement what occurs inside the snark. So you can do the curve operations. So you can actually use this to provide basically an equivalent of a digital signature without having to even reveal your public key. So if there already was an existing system, you might be able to, probably not, because the curve wouldn't probably be the same. But theoretically, you could do some cool stuff. You can also use them to achieve Peterson commitments, which are more efficient than just a SHA-56 one that have a lot of additional functions on it. So go to the next slide. So today was intended to play around with this tool. It's play on the philosopher's name, but because I love Bill and Ted so much, I'll just refer to it as zk-SNARKs. It's probably a practice, but zk-SNARKs is a better sound for me. So this is a Rust toolbox, Rust-based, that is a wraparound LoopSnark, but they provide their own programming language where you can write in a relatively high-level code compared to C++ templates that actually generates proofs for you, completes the setup. You can use to export a verifying solidity smart contract that you can use on the Ethereum network. So that's the tool. I think we'll start the next part of it. Go to the next slide. So if you're going to follow along with this, the easiest way to do this is just using Docker. So if you have Docker set up, feel free to just open up a laptop and get ready to just check out a container. You'd also need Git, and if you're going to try to verify a proof, because they only export a Solidity contract, you'll need some way to verify that. You could what's the name of the tool, the web one? Remix? Yeah, you could use Remix if you wanted, but I just use Truffle and Ganache to just run your own local Ethereum node and perform verifications there. So if you wanted to get the container, this is the command to use. It'll just check out the container for you. Take a little while, but it's already got a compiled binary for you, and you can just run the program. I've ran into problems where I forgot that I had already checked this out. No, the code examples work. So if you've already played with it before, I don't know if you have JSON, maybe update containers. So next slide. So there's two little kind of things in here, examples. The first one is basically the hands-on one that they cover on their website. GitHub page. So here I'm running it as a root user just so I can install again the edit code. So just creating a file. We can look at the code example. That's the next slide. So this will be an example proof where you're going to prove that you know the square root to a number that is public. So theoretically, be a large number. You just prove that you know the square root to it without having to reveal what it is. The main number would be public. So this is the language. It's kind of influenced by Python. You declare, it's got a main function though. So main is your entry point. And this is a visibility specifier that's a little different than normal programming. Here you're describing what variables are public and private. So A would be the actual square root value, because you know it's private. It will not actually be public in the final proof. Field B is a public input, and we have field as a type. So because we're using the elliptic curves, we are representing elements as an element of the curve. So we're using them to represent numerical values, but it's like a 254-bit prime number is like acting as a modulus. So that's the biggest value you can represent. So these operations that you do, like multiplication is basically multiplication, just modular multiplication. All the operations are modular. So division is going to be weird. If you do like 1 divided by 2, you get a very large number because it's
being modified with config. This is another weird thing about this language. Because what you're writing becomes a circuit, every single logic gate is accounted for in the final result, and every single intermediate value is always stored, basically. So you have to write your circuits in kind of a strange way. Like an if statement with a lot of code here. You've got to do, like, create a variable to kind of determine that, and then basically multiply every single thing by whatever this result was. So you can do an if statement, but it's basically like an inline if. You can't do like nested conditions very well. It's a limited language, but you can make it work. So simple, if A times A is equal to B, then result is 1, else it is 0. And then this one, here's the return type field element. So that's relatively like a clean, straightforward example. Language does not have many more features than this. It's very limited.
So is this it? Is this proving that they're not
This is the
multiply the two A's if it equals that is.
This is writing the program. So this, remember we start source, rank one constraint system, plot, and then on the reference string.
Right.
This is the source.
But yeah, but
this is the circuit. This is the circuit. We'll sort of go into the next step. So once you save that file as root.code, it's a terrible extension for something like this, but next slide, yeah. So zk-SNARKs is set up with like git style subcommand. So there's a few different commands that you really ever need to compile, and then you pass it the path to the source code, and it will compile it and generate the rank one constraint system, R1CS. And you do setup, and then from there it takes the R1CS, turns it into a plot, and then generates the on the left constraint, your parameters, your keys. And then you do what's called computing witness. I touched on this a little bit, saying that all intermediate variables have to have values. This actually does that computation. So it's going to set everything. You end up with like a matrix of all these variables. And then you generate a proof where it samples some random numbers. But random numbers are sampled here as well. So this generates them, multiplies them by your witness to blind it, so no one can actually see what you input for the private inputs. And then because it's using the proven key, it can be verified using the verification key. And you were going to actually try to verify this proof, you can track the file, container, this command, put it in Windows. It won't work exactly. You'll just have to do .ps and then get the computer ID set and place it there. Next slide.
So you're exporting the proof,
yeah,
but not the outcome of every.
Right, you just export the proof. You would export the verification key. I think that might be the next slide. Yeah, so if you're going to export it, this generates a Solidity smart contract for you. Just .sol, and it's Solidity language. And they export that as well here. And I set up a repo if you wanted to actually play with this using Truffle, which is here after all the framework. Pretty like boilerplate. All you need to do is add in your verifier and a proof file, and it's got stuff set up for you to be able to actually verify things as well. So we exported it. Now in another terminal, I'm going to here cloning the repo, doing the verifier contract. I'm using Ganache as my local test node, and I'm just running as a background process. Next slide. So I enter the Truffle console usually, and so I tell it to compile a smart contract. It compiles because I set up this repo to use the correct version of Solc. Otherwise, you get compilation errors. So there's like a particular version you have to target because they haven't updated the template that they use to generate the verifying contract. So that repo is helpful mostly for just getting the basic config out of the way. And then you do migrate, which deploys your compiled contract to your local node because it's set up to run with the default Ganache point. And so here I retrieve the verifier kind of interface, and here I load this script that basically all it does is reads the JSON file that you exported earlier and then hands it to you in a way. passed to the verify function. And this function just returns a true or false, whether or not it's valid. And you could use this within a smart contract to perform different things depending on whether or not you give a valid proof. This is just like a boilerplate, hello world kind of example. And if you were to try this, you would see after about 1 second, true. And it's always satisfying once you actually get it working. Because there's a lot of stuff involved and a lot of places to go wrong. But now we get to go to the more complicated example, I guess.
So what was the P0, P1?
Oh, so this is just straight, this is JavaScript. So it's just, this is the proof. So I guess this is a little technical. This is using the BCTV 14 proving system, where the proof requires an A prime, a B prime, a C prime, an H, a K, and then the array of all the inputs, including 1, because it does some multiplication, so it needs a reference point to see what all these other values are for the verification process. But these correspond to the proving and verification keys. So the proving key generated a bunch of A's, a bunch of A primes, et cetera, and then the verification key generated an A, just one, an A prime, a B prime, and then it's going to do this multiplication to see whether or not it matches this parity check for all the A's, all the B's, and all the C's, and then checking whether or not all of them together are consistent. So that's like getting a little technical into the proving system. Basically, the proof has all these components. It's not just a single number, it's a bunch of numbers. And so I'm just passing them all through the interface that the Solidity verifier contract requires. So next slide. So that was just a simple proving a square root. If you want to do something more complicated, like actually doing a password using this tool, we can. When I started playing with this tool before, when it originally launched, like November 2017, they announced it at, they released it at DevCon 3. I started playing with it immediately, ran into a bunch of issues. There's like less than and greater than kind of operations you can do. And the less than had a bug at the time, and there wasn't any visibility specifiers. You had to input stuff interactively. You didn't really have types. You didn't have declared return types. And so there was no interoperability with the libsnark gadgets either. So you had to implement SHA-256 yourself. And I did that using this language. And it generated, I think it was 2 million constraints. If you were to actually try to compute a proof using that, you would need like more, you would need like 32 terabytes of RAM to actually generate that. But because they've updated it to use the existing libsnark gadgets, which are using more efficient C++ to implement a lot of these things with a lot of optimizations, they've got it down to something like 25,000 constraints in libsnark, and with the wrapping part of it, it brings in about 28,000, which is a lot. You can verify it in like not even a second.
Oh.
So it's a lot quicker than a million constraints.
Sort of the next question, how fast or slow is it?
Yeah, it's not too bad for larger circuits. If you're doing Merkle trees and whatnot, it's going to take a lot longer, especially if you're using SHA-256. You can use different hash functions though that are more efficient. Basically, they just have less constraints, and so you have to weigh like the security implications of using something that is not secure as SHA-256. A lot of these are new things that haven't had formal security audits yet.
My grandmother got it down to 23,000 constraints.
Oh, really? Yeah. That's impressive. No, at DevCon 4, I saw a talk, and they've got some new like Peterson-based kind of commitments that are like only 1,000 constraints. It's like insane if it's actually provably secure, because then you can do Merkle tree kind of things. Because originally Zcash launched, it could take about like 10 minutes to generate a zero-knowledge proof. Now with their new curve, and since they're using JubJub and embedded curve inside that, they're using ECC for their operations to implement Peterson commitments that have less constraints. So I haven't actually updated my node. It's dead right now. So I don't know how long it takes right now, but it's a lot quicker, and it's actually something you could theoretically do on a mobile device, and they are working on implementation.
That'd be powerful.
Yeah, it would.
Really powerful.
So we'll go into the next example now, which is a more advanced version of the one they have up. The one they have up is it's using SHA-256, but it pads whatever input you give to 512 bits. So if you just use like Pythons, like hashlib,
SHA-256 and you just pass in a string, you're going to get different results. So the one I implemented is one where you get the same results if you pass in the same thing to hashlet. So you can just use Python, hashlet, create a hash, and then that's actually how I generated this. I just used the output and then had zk-SNARKs generate all the intermediate variables and actually was correct.
So it's any arbitrary binary file.
Theoretically, but within your context of your system, because it generates a circuit, you probably want to optimize that to get it down to only, because it's going to unroll every single loop, generate a fixed circuit that you have to reuse several times. So, like Zcash,
so
you have no
bounds to it. That's what I'm wondering.
What's that?
There are some size boundaries. That
yeah. You have to take into context whatever system you're making this for, and then get it down to the bare minimum for that system. Because this will only do, the one that we're doing in this example will only do one block. If you want to do multiple blocks with longer inputs, you'll have more constraints, and you'll have to update the code a little bit more to do that. So we'll go to the next slide. This is just a hash that we're going to try to create a proof for. Now, because it exposes libsnark a little bit, and the implementation that they did in their one is to get it as like clean as possible. The one I did to try to get the full version to work just as a simple hashlet example, that's a little bit more complicated, and the language doesn't really offer a helpful thing, partially because you can't represent values bigger than 254 bits. That's like the biggest value you can have in a single variable. And so SHA-256 operates on 512-bit blocks. So you have to use multiple variables. And then actually when you look at the libsnark implementation, they have to make sure everything's Boolean based. So they actually break everything down into a single variable. So you're decomposing all your inputs. So for 512 bits, we end up with 512 variables just for the input to SHA-256. And then we also have another 256 for the outputs. Then we have another 256 for computed outputs. And then we have another 256 verifying that all of them are the same. So the code gets messy. If you go to the next slide, we'll just see kind of high-level pseudocode that sort of explains what you have to do. I try to get it as clean as possible, matching their API for the function, which is the main function. So we've got we've got 4 field elements representing the inputted 512-bit block that you have to pad yourself, but I have a Python script that'll compute the padding for you. So we've got 4 of these, and we each represent 128 bits of it. So you just take the full thing, chop it up 4 times, convert it to an integer, basically, and you pass them in that order. And then you do the same thing for the hash output. This is public. The other ones are private. The public ones are the purple. This is the lighter purple. So those are public, and so here we unpack using this function. This is commented out, or just like pseudocode sort of, just describing what you need to do. Get 212 ones for the input, 56 for the password. Then we use the suppression one, which has 512 arguments. We compute the computed hash, and then we just assert everything valid. And it's perfectly acceptable to just return 1 in your program, because if it doesn't, none of the conditions actually need in a proof. The proof wouldn't be valid. It's just if you wanted it to also have outputs, you have to have a return value at least. So if you wanted it to return other stuff, it's something you could do. In this case, it's just we'll return true, and it will die if it fails, basically. The next slide, here's the real code, and it's really tiny. I had to make it, it's set up to where you can double click, copy it, and then paste it into a file. It actually goes on beyond here. So these are all like a shirt. So
really?
Yeah. Next slide, you'll see the Python script that generated that. That might be a little bit more clear, because I'm not going to hand write that code. I've very gone through that fun process.
Oops.
So there's a Python script that just random helper methods to just generate each line. So then next would be just running the actual program. Next slide. It's pretty much the exact same process. So you compile the program. This takes a little bit longer than the simple square root example. Setup, again, takes a little bit longer. This is the most intensive phase if you're doing a system. This is also the most risky phase, and that's something we'll have to touch on in the question. But here we compute the witness. So if you remember back at the beginning, the hash
just black with white things. So this, there's 4 of these, 1 and then 2 zeros and 24. If you ever look at the specifications for Cal56, you take your hash, or whatever, you take your pre-image, you append 1, then a bunch of zeros, filling it up to 512 bits. But you reserve the last last byte to say the length of the input. And so that's basically what this is. This is the input that produces a hash. This is a Python script to generate this for you. The next one is the hash split up. So it's 256. We split it up 128 bits and then another 128 bits. This computes the proof. Does not take too long. Then we generate. Well, that computes all the intermediate variables. Then you do the multiplications, just generating the actual curve points that you're going to pass to the contract. Looks like there's a bug though right now with zoke rates where inputs. I guess if we had it up, we could look at the actual proof JSON file. There's the A prime, B prime, C prime, H, K, and that's basically under proof. But there's also inputs. Just because of the way like Web3.js works, it being JavaScript with the max values and nums being too small. Yeah, those should be passed in as strings to the verifier contract, but the inputs right now are trying to become JavaScript numbers, so you just have to convert them to that, otherwise they won't get converted correctly and then it won't verify properly. So you just export it and then put quotes around whatever values don't happen. Next slide. Verification is pretty much exactly the same way. Generate the Solidity smart contract, run this command, enter Ganache. Next slide. Temporal console, compile. If you have already been running Ganache, you'll want to reset when you migrate, deploy a new instance. And from there on, it's the exact same verification code. And it's kind of cool when it actually works. And I can show you guys if you want, but it's like
why don't we I'm thinking maybe after lunch,
okay,
you could do like a gather around workshop, and maybe we can tie it to one of these monitors, or maybe even get it connected to that monitor. Does that sound okay?
Yeah. So I think the last slide is just like the question slide. Oh, I already touched on this a little bit. So simulation extractability, throughput protection. The password example we used right there, though it's more closer to being ready for production use than the toy example that they gave. This is still, because we're using BCTD14, it's not, doesn't provide simulation extractability, so people could reuse your proofs. So you have to either switch to something like GN17, which I'm not actually sure if you can implement in a way that will run on the Ethereum network right now. Or you can do something similar to Zcash where you have basically unique challenges, but you'd have to do another step before this to actually have data pegged to hashes that you can verify in another way. It's just, we got the first half of it down, I think, and that's good enough for playing with this stuff. The next slide is probably the question slide. So are there any questions?
Well, this seems like a lot of overhead to run.
Oh, it is.
Is that something that you have to do every time you do a transaction?
No, once you export the verifier, all someone needs to do is just use compute proof. They don't have to go through the setup phase. They don't even technically need the original source code at that point. They just have the proving key, and they need the R1CS.
Oh.
And then they can just generate proofs, and it doesn't take too long. Just this is from the kind of full setup kind of perspective where you have to go through the setup.
You only set up once.
Yeah, and I don't actually use zoke rates. I use LoopSnark directly for my project, but I'm just like happily surprised that they've gotten a lot more progress made from when they originally started using it. It's probably something you will be able to use in production systems at some point.
Well, what's the point? At what point?
Well,
is it close? Is it far
it's
from there?
good enough to start playing with it, I think, and it's really a great entry point into LibSnark because you can look through the code and see how they call into LibSnark and actually deal with that C++ library. Gadget Move 1 is a nightmare, but that's how I got started with LibSnark. Played with the original version, like, this isn't working, why isn't the lesson working? And then giving the code, it's like, oh, so C++, template arguments, and the template arguments are the proving system, and then you have another document for the curve you want to use. Okay, and then you have to, LibSNARK's a little different. You don't actually write source code in a high-level language. You have to write out each constraint manually, and then write out how you populate those in another function. And it's really not fun to deal with. And the way the gaps are managed, they are composable and all that, but you can theoretically do that with zk-SNARKs as well. So it's a much better tool. There's a huge dependency issue with libsnark, a lot of different versions of it are circulating around. I think zk-SNARKs is using the deprecated master though. They've refactored all their code base. If you want to use other proving systems on Ethereum though, other than BCV14, you still have to modify libsnark yourself right now. Because the growth 16 implementation generates a point that you can actually use, so you have to decompose that down to 2 group 1 points instead of group 2. But it's all technical stuff. Getting started with zero knowledge proofs, use zk-SNARKs. It's really cool.
Cool.
Right.
All right. So why don't we stop the screen share? What I'm thinking is pizza's here. It's hot. Let's go ahead and break for lunch until about 12:30 because it's 11:21 now. So let's say lunch between now and 12:30. And in that time, we'll see if we can hook up your laptop to one of these monitors, and then you can go into the code. And because is everybody interested in this? I think it's fascinating.
Yeah, I can see.
Myself. And then we'll see how it goes after that. What I'm thinking is it would be cool to kind of maybe break the group in half and talk for an hour or so about, what you're getting out of this. If you see any ideas that you'd like to pursue, then we'll come back and we'll just kind of do that. If you want to put together a presentation, great. If you don't, we'll just kind of do a summary and wrap up and, call it a day if that sounds good to everybody else. And then a week from, next Thursday, assume that at least from, in the evening, you'll be able to come to Dezer Blockchain camps and we can continue the conversation both on Thursday night and Friday night. I assume everybody's kind of busy during the day, and then we'll open it up on Saturday as well. So does that sound like a workable plan?
Yeah.
Cool. All right, well, we'll conclude the morning live stream, and we'll be, we won't reconvene. I'm going to conclude the live stream until we do the summary part. So anybody watching this, I'll set up a live stream for when we come back and everybody kind of shares what they got out of today and what they see for future steps. Does that sound okay? All right.